We've been waiting for 5 minutes to get through emergency. I hope someone comes immediately.
I understand, ma'am. Just verify the address one more time to make sure we have that correct.
When you see how quickly they have to move on a serious call like that, you can understand the frustration and concern on the days when they can't get to those Category 1 calls because they're queuing outside hospitals. This time they were able to save the patient, but at the moment there are no guarantees.
12 investigators listened to the entire 911 call. Frustration was evident within the first minute.
Panicking at this point. I'm inside. I'm frustrated, probably grumbling, and I wait another 6 minutes when I call back the second time.
The question is, until when?
Rodney Pierce, the Davie County 911 Communications Director, says it wasn't numbers, but rather letters that became an issue.
Imagine the insurance cutting through the city. Every second counts, right? But the biggest enemy isn't mechanical failure, it's traffic.
A 2024 survey of first responder agencies conducted by LYT revealed that a stunning 41.7% of vacancy.
내면 traffic congestion, a state of mind hurdle to improving response times.
That means almost half of all emergency service constantly losing critical minutes.
Up here deserves better, yes.
When Brenda Sorsdal's grandson needed help, the ambulance crew went to the wrong address in Park Rapids. WCCO's Liz Collin explains how the mistake could have been avoided.
We enter the main point. Let's say ambulance pits traffic. The next disaster often stems from a breakdown in human communication.
That 911 call made that night makes it clear that there were multiple factors contributing to that confusion. The house number, the victim's condition, and perhaps most importantly, which side of the highway the house was on. I do want to warn you, some of this report may be tough to hear.
The United Kingdom Judiciary's Prevention of Federal Deaths reports clearly expose
specific reports document cases where control center staff either failed to correctly establish the patient location due to addresses that were confusing, or committed critical error by suggesting a different wrong street to the caller house,
delaying the crews from reaching the patients. This isn't just a mob glitch.
This is a failure of operational protocol and clear communication during the most stressful minutes of a call.
So, when the basic delay of traffic combined with the failure of communicational protocol and wrong addresses, what discussion time?
But here is the terrifying part. During this agonizing wait, there is zero clarity. Without accessible real-time tracking, families are left in an information blackout, clinging to vague ETAs, never knowing if the ambulance is 1 mile away or stuck 10 miles back.
During my internship from February to June 2025 at the Communication Informatics Department of Matthew City as a software and machine learning engineer on the research and development team, I contributed to developing Pantau Matthew application. Well, Matthew already has an emergency call system similar to 911 called Matthew Seka 112. But its operational workflow still relies heavily on traditional methods, where citizens must call a hotline, speak with operators who manually dispatch ambulances, and then repeatedly call back asking about the ambulance's location and estimated arrival time. This repetitive inquiry pattern not only overwhelmed call center staff, but also create anxiety for patients and their families who have no visibility into whether help is actually on the way. The Pantau Matthew application addresses these critical gaps through a comprehensive mobile architecture built on Flutter for cross-platform front-end development, Node.js with Express for the backend API server, MySQL for relational database management, and Java Development Kit as a foundational build environment. The system integrates several interconnected features designed to solve both communication breakdown and traffic-related delay. The users begin by registering through a detailed form that captures nearby data, which ambulance crews can access directly without repeatedly contacting dispatch. The login pads provide immediate access to emergency service, including direct dial buttons for Matthew Seka 112, with sub-integration with Awasiga, the city complaint service, and link to official government resources. The core feature is an interactive map powered by OpenStreetMap API that displays real-time ambulance location through GPS tracking, which an administrator can activate or deactivate through a dedicated admin panel. For ambulance drivers, this panel also manages ambulance status indicators showing whether units are available, responding to calls and chat, or transporting patients. To address traffic congestion specifically, the application integrates TomTom Traffic API to display color-coded road density information across the different city zone, allowing both ambulance drivers and patients to anticipate delays and potentially suggest alternate routes. The weather panel, powered by OpenMedia API, provides current condition and forecast that might affect travel time. Perhaps, most importantly, the chat features enable direct real-time communication between users and ambulance crews, eliminating the call center bottleneck entirely while keeping operators informed through an input system. The forum and comment sections create a community-driven traffic reporting system where residents can share real-time updates about road closures, accident, waiting processions, blocking streets, or other obstacles that automated traffic API might miss. Profile and emergency call tabs are intentionally designed with large, simple interface to accommodate elderly users who might struggle with complex navigation during stressful situations. The system, of course, has advantages and disadvantages. First, the real-time GPS tracking dramatically reduces patient anxiety and call center workloads by providing visible proof that help is on the way. While the TomTom traffic integrations allow ambulance drivers to practically avoid congested roads, so potentially saving crucial minutes during emergencies. Second, the direct chat features eliminate communication distortions through intermediaries. The system also has challenges, including GPS accuracy issues and blurred signal area, plus dependency on stable internet connectivity that call fail during disasters when most needed. Nevertheless, this application provides a comprehensive overview of ambulance positioning, traffic conditions, and direct communication channels, so enabling informed decision-making not only by EMS personnel, but also by people surrounding the patients themselves. Family members can see exactly where help is, anticipate arrival times, communicate alternative routes, or critical information directly to ambulance crews. As a continuous development initiative from the existing Madiun Sega 112 emergency service and the Awak Sigap compliance systems, these platforms represent an evolutionary step towards integrating fragmented public service into a unified, accessible digital ecosystems. I plan to make this project open source in GitHub so we can collaborate to create more innovations and enhancements, such as the advanced functionalities as we discussed previously, machine learning alert detections, voice commands for hands-free operation, or hospital system integration. By making the code base publicly available, I hope to foster a collaborative environment where innovative solutions emerge from diverse perspectives and expertise. Every contribution, whether fixing bugs, suggesting features, or adapting the system for new contexts, bring us closer to a future where emergency response is faster and more equitable. Join me to making emergency medical service more functional and effective for communities. Thank you.
Minutes matter in any situation.